Bluetooth connected. Okie doke. This is here. Just try to run this, see if it works. Still chasing. Okay. Excellent. VS Code. Okay.
Hello and welcome. In this lecture, we're going to be getting our AI to be patrolling back and forth between our locations. So it'll go to my original start location, then it'll go back to his start location, wait a little bit, and then go again. We're going to be achieving this via our behavior trees. So let's dive in and see how it's done. So up to now, we haven't made much use of our behavior tree. Let's fix that. We're going to create a behavior that allows us to go from the place where we're starting to the player's location, and then go back to our original starting location. Now, the way we're going to do this is using the following. So there is a distinction in behavior trees between things called tasks and things called composite nodes, or in this case, the example of the composite node is a sequence. So let's understand sequences and tasks. As they kind of sound, a task is something you do. A sequence is a sequence of such tasks, and it will...
All right. I think Momo's dookie right now. I'm gonna put this food away.
run all of the tasks in order. So if we right click and expand out the tasks here, you can see an example of what could be used as a task. For example, we can have move to, which moves to a location. There's move directly to as well. I'm not entirely sure of the distinction. We're going to be using move to. You can get it to play an animation, such as a scratch your nose animation. You can get them to play a sound like, hey, you, that sort of stuff. You can get it to run another anime behavior if you want to. There's also a wait here, which is very useful for adding in some pauses into your behavior. Now, what's interesting about these tasks is that they can run for multiple frames, for multiple ticks. So move to will be running the entire time that you are moving to a location, and it'll only finish when you get there. So if we did a move to, and we can stick it in a sequence here by just dragging down from the sequence node, then what you're going to get is, first of all, it's going to try and move to the destination. And then we could add in a second task node, which tells it to wait. And then we can add in a third task node. Notice I'm pulling down from the sequence here and releasing, which allows me to add in a task quite quickly underneath that sequence node. And then I can tell it I want to move to another location, and then I can tell it I want to wait again for a certain amount of time. Now, this is the basics of that moving to the player and then moving back to where we started from. And you can see how the sequence node is working here. Now, there's a root node as well. The root node can only have one child node, so don't try and add more things under that. So we've got one sequence node as the root here, and that's basically saying that I'm going to run all of these tasks in order until one of them fails. And then once we're finished, we can start the process again.
Heat, Mo. Get out of here.
So the other thing to note here is that if you click on any one of these nodes, the details over here give us some impact over how that node works. For example, our move to currently takes a Blackboard key in the Blackboard section of its details pane of self-active. We can change that over to the player location. So that's basically saying this move to node will now move to our player location. Then we're going to wait 5 seconds by default, but we can change that again to say we might want to wait 2 seconds. And you might want to have a random deviation of 1 second. So that basically it'll be waiting somewhere between 1 second and 3 seconds. To our player location. Then we're going to wait 5 seconds. It takes a Blackboard key in the Blackboard section of its details pane of self-active. We can change that over to the player location. So that's basically saying this move to node will now move to our player location. Then we're going to wait 5 seconds by default, but we can change that again to say we might want to wait 2 seconds. And you might want to have a random deviation of 1 second. So that basically it'll be waiting somewhere between 1 second and 3 seconds. And then we want to move to a different location. And that's a location that we don't currently have, which is our start location. So we can go ahead and add that. Let's go over to our Blackboard, add a new key, add a vector, and have that as our start location. And then we can go back over to the behavior tree and see that our move to node, if we go to the details pane, now has the start location as an option. And then we might say we want to wait 5 seconds, and then the process will start again because we'll have successfully completed our sequence node. So this is how it works. You step down into the sequence node. The sequence node then says, okay, well, where am I at? I want to start at the beginning. And you can see these numberings here are telling us the execution order. We start at 0, which is the sequence node, 1 is the move to, then 2 is the wait, 3 is move to, 4, etc. So we step through doing each task until completion or failure. If we fail, then the sequence node will fail as a whole. None of these are likely to fail, however, so we'll go through the whole thing. And then the sequence node will complete and the route will start it again. So we're going to go through in a loop, going to the player location, waiting, going back to the start location, waiting for a little bit longer. So that's the power of behavior trees. And you can start to nest these deeper. You can have choices in here. You can have decorators, all the stuff that we're going to see in upcoming lectures. But this is the basis of it, a series of instructions that your AI can run and they can take more than one frame to complete. Now, what we want to do is actually set this start location to be something meaningful. Now, that should be reasonably straightforward. The only thing I probably want to tell you how to do is how do we get hold of the pawn that we're in control of. So just a reminder that if we go over to the controller.h here, then we can have a look for the get pawn, and the get pawn method for both player controllers and AI controllers allows us to get hold of the pawn that is being controlled. So you can use this to get the pawn being controlled and get its location at begin play in order to set our start location. So here's the challenge to you. Set a start location, get the pawn's location as we've just talked a little bit about, set the correct Blackboard key, use the player position that we've already used as a template for that, set up the behavior tree the way I have in the lecture and test it out. See if that behavior gets the desired behavior of the player or the enemy moving to the player's pawn and then back to its original starting location.
See if this compiles.
pause the video and have a go. Okay, welcome back. So hopefully that worked out for you. Let's give it a shot. So I'm going to copy the line for our player location. And instead of setting the player location, we'll go over to our Blackboard, have a look at our start location. We're going to copy that key value in here. And then instead of getting the actor location of the player pawn, we're going to do a get pawn and then get actor location, which is going to get the pawn that we're currently controlling and get its location in the world. So we can go ahead and go back to the editor and compile this. And once that's done, hit play and have a look at our pawn. He comes over, moves towards us, it waits 3 seconds or
You're kind of stinky. Why are you stinky? This just diamond? Ma'am.
two seconds or 1
Well, my mouse just decided to not work. Where that went into. All right, okay. Oh, this mouse stinks. I literally can't even use this. literally cannot even use this. Oh, there we go. We're back. We're back. Okay.
In the blueprint, what behavior tree we want it to run. So the first thing I'm going to do is I'm actually going to go over to the AI controller CPP and comment out the stuff in tick, because we're going to be replacing this functionality with behavior tree functionality instead. And then that means that I can remove this acceptance radius here because we no longer need it. And instead we're going to be using a pointer to the U behavior, and I have to spell this the American way, tree and pointer. That's the behavior tree we want there. And I need to forward declare this with a class in front of it. And then basically here, what I want to say is that this is the AI behavior, and I'm going to keep the American spelling here just for consistency. So this is the AI behavior that we want here. Now to actually run the behavior, it couldn't be simpler. Again, the AI control.h has a built-in function for this. We've got this run behavior tree function, turns a Boolean whether you are able to successfully execute it or not, start executing it that is, and it takes in the BT asset, which is a pointer to the U behavior tree. So that's what we're going to want to use, and we can do this over in begin play. So what we're going to do is, first of all, we're going to check that we indeed have a behavior tree here. So we're going to say AI behavior is not equal to a null pointer, because we do not want to be using it otherwise. And then what we can do is we can run the behavior tree called AI behavior. It really is that simple to get an AI behavior running. And we can go ahead and compile. And one more thing we can do with behavior trees is we can kind of see them running at runtime. But to do that, you need to have some sort of node in here. So we're just going to add in a node without fully understanding what it does. I'm going to add in a sequence node, and I'm going to hook it up by dragging down from the root node, the bit underneath the root node that highlights when I mouse over it, down to the bit above the sequence node. And I'm going to save that. I'm going to go over and hit play and go into my behavior tree asset. And you should be able to see a drop down here, but we're not, because it's not currently running. So let's stop playing. And why is it not running? Because we haven't hooked it up in our Shooter AI controller. So let's do that. May challenge for you to hook that up. Hopefully it shouldn't be too hard. Okay, welcome back. So if we go and have a look in here, we're looking for our AI behavior. For some reason, it required a recompile for me to show up for me, but here it is, AI behavior is what we want. We click the drop down. There's only one option at the moment because we've only got one behavior tree. So let's select that one and compile and save. And if we now go ahead and play the game, and go and have a look at our BT enemy AI, you can see that it's highlighting the node that's currently running. And you've got this little drop down next to the pause stop buttons, which tells you which AI controller you're currently observing the behavior tree of. So this is a great functionality for you to be able to jump in and go, okay, why is that AI just standing still? Why is he not chasing the player? You can see which part of the behavior he's currently running and go, that thing's gone wrong. It's really helpful for debugging. You can go and have a look at what all your AI in the world are up to by using this drop down. Great stuff. That's all for this lecture. In the next lecture, we're going to be looking at how we can seconds or 1 second, then goes back to his original start location, then he waits 5 seconds, and then he comes back over to that original location of the player pawn. So he's not updating that every frame. That's okay, that's how we designed it at the moment, but you can see the behavior going on. He's patrolling back and forth. So let's have a little look at all of this in action. Have a look at our behavior tree. If we go over to our behavior tree and select the AI in question, you can see where he's at. He's moving to, he's waiting so many seconds, then he's moving to his start location, he's waiting again. So we can undock this and see both of these things happening at the same time in our game. You can see he's moving to that location, he's waiting now. He is back to moving to his start location. So this is really handy for us to be able to debug, especially when these behaviors get a little bit more complicated. And it also gives you a sense of how Unreal is calculating the behavior tree and how that execution flow is working within our behavior tree. Great stuff. In the next lecture, we're going to make these behaviors even more complicated and add some element of decision to whether we choose to follow a player or whether we choose to stay put where we are. I'll see you in that lecture. Hello and welcome. In this lecture, we are going to be looking at having some choice in our behavior trees such that I can have our enemy run towards me. And if he loses sight of me, he comes to my last known location, doing basically two behaviors, a chase and then an investigate behavior. Let's dive in and see how that's achievable using behavior trees. So while this patrolling behavior is very instructive, it's not really the kind of behavior that we want to implement. What we'd rather have is something along the following lines. When we can see the player, we go and move as close to them as we possibly can. And when the player goes out of sight, then we try and move to the last known location of the player to find them. And once we have exhausted that option, maybe we go back to a different location, or maybe we just stay there for now. So how can we achieve this? Well, at the moment, we've got no way of achieving this with a sequence of actions. We need to make a choice based on the data that we have available. We need to choose between whether we can see the player or whether we can't, whether we've got a last known player location or not. That sort of thing. So to do this, we need a new type of node in the behavior tree called a selector node. So if we right click and look at our composites, one of the options there is the selector. Now the selector, as opposed to the sequence, runs thusly. If you have a bunch of tasks underneath the selector, it is going to run until the first one succeeds. And basically it's expecting all of them to fail until one of them succeeds. Now the sequence did the opposite. It runs all of them until one of them fails. So why is that useful? Why is it useful that the selector runs one of them until one of them succeeds? Because basically we want it to choose the first option that is viable. Now, the way we're going to do this is not by actually running tasks underneath the selector, but running sequences underneath the selector. So at the root level, we're going to be doing a selector node. And then beneath that, let's just move this sequence aside and create other sequences. We're going to have one sequence over here. And what we can do is we can actually rename these sequence from being sequence to something like chase. And then we can add in another sequence here, which is going to be along of the lines of investigate. And these are basically add to...
How did you rename this?
One sequence over here, and what we can do is we can actually rename these sequence from being sequence to something like chase. Add in another sequence here, which is going to be along of the lines of investigate. And these are basically our two behaviors that we want to be able to choose between. And in order to make them fail, we can add things to nodes called decorators. So if you right click on a node and go add decorator, you can see here there's a bunch of options here. And they basically change the way this node works. Then they can do that in a number of ways. For example, we've got this conditional loop, which allows you to loop through all the actions again in the sequence as many times as this conditional is correct. We've got other things here like a cone check, which is about visibility, and other such lovely things. We've got just a pure loop, got a time limit, so we can only stay inside this sequence for a certain amount of time. Basically, lots of things that modify the behavior of this sequence. But the one that we are interested in is the blackboard, because this is a blackboard condition. And as you can see from the writing underneath of it, the default is something along the lines of, is this self-actor set? And if this is not set, then automatically this node and everything underneath it will fail, which means that our selector will go on to option 2, which is investigate. So in this case, we actually want to change this up. We want to change how this works. So our player location, we want this to be such that it is only set when the player is visible. And then we want to add in a new variable here, again, a vector, which is going to be the last known player location. And the last known player location, when the player is visible, is going to be the same. But once the player becomes invisible, the player location gets unset, and the last known player location is where we're going to want to go. So we can do this by going to our blackboard base condition and just changing it to being the query to be, yes, is set, but the thing that we want to be is set is the player location. So if the player location is set, then we're going to give chase. And we're going to give chase by doing basically just a move to, and we're going to move to the set, but the thing that we want to be is set is the player location. So if the player location is set, then we're going to give chase. And we're going to give chase by doing basically just a move to, and we're going to move to the player location like so. Now, we're not doing much else under this sequence. So in actual fact, you could put this blackboard condition directly on the move to, but because we might want to do other things such as shooting, I'm going to leave it as a sequence for now. And then we've got this investigate. Investigate is basically also going to do a move to, but it's going to move to, instead of moving to the player location, it's going to move to the last known player location. And you can see we don't have a condition on that because this falls through if this condition fails. One important thing to note about these Blackboard conditions is that by default, once we have made the decision to start executing this node, we're not going to reevaluate that. So if for some reason we lose sight of the player while we're moving to that player's location, we're going to keep trying to get there. So if we want it to be able to abort the execution of this node, then there's an option for that. If you go to the flow control, there's notify observers, and there is underneath it observer aborts. At the moment, set to none, but you can select from a couple of options. You can set it to self. So this is saying if this condition suddenly becomes false, then stop whatever you're doing and re-evaluate your selector and see maybe we now need to do the investigate node. The other option here is lower priority, and you can see that it's changed what's highlighted. Here it's saying if suddenly this Blackboard condition became true, stop whatever else we were doing and start executing this chase condition. And then the final option is both. And this is the one that we want. Basically, it's saying that this Blackboard-based condition, if it becomes true, we start executing the sequence immediately. If it becomes false, we stop executing it immediately or stop executing whatever else was going on. We just basically want to always go and do whatever path is dictated by this Blackboard condition. So hopefully that makes sense, that the observer aborts stop things in action. Otherwise, it will wait until the action is finished before re-evaluating. So really now we want to go ahead and implement our last known player location and player location, because at the moment, if we go over to our C++ and give ourselves a little bit more room, then you can see that we're only setting this player location in begin play. Ideally, we'd be doing this every time we have line of sight to our player pawn. So we can actually uncomment our line of sight code here, and we probably want to uncomment the else code as well. But we're not, in this case, going to be clearing focus and stopping movement directly. I can go ahead and remove these entirely because that's not the way we're doing things at the moment. Instead, what we want to be doing, if I remove the code, is we want to be in here setting the player location. We also want to be setting the last known location there. And in else, we want to clear the player location. Now, to do that, we have got a function available to us, which is, instead of the set value as vector, if we go ahead and open our Blackboard component.h, there is a clear our, which is, to do that, we have got a function available to us, which is, instead of the set value as vector, if we go ahead and open our Blackboard component.h, there is a clear value. And this just takes the fname, doesn't need to take a type or anything, or because we're just completely erasing whatever was in that variable. So here I've got the challenge for you to fill out our tick, set the two variables when line of sight, basically fill out this first bit of the
Doing.
if statement, and then clear the player location when we have the else. So when we lose line of sight, we don't have a player location anymore. Reduce the speed of the enemy that's in the world so that you can get away from him more easily. And then check the functionality. Check that you're able to hide behind a corner and that he goes to the last known location to try and find you. Pause the video and have a go at this. Okay, welcome back. So let's give this a shot. First of all, we're setting the player location. I'm going to move that out of begin play and move it here instead. So we're going to set the player location to, we need to be getting the player pawn here and tick again. So I'll uncomment that line. And then we're doing exactly the same thing, exactly the same line of code for our last known player location here. So let's go to our blackboard and just make sure we copy it so we get exactly the same name. And then we just want to clear that. The final thing is to clear our player location here. So it's going to be clear value, and it's going to take this text player location as the value that we're trying to clear at the end. And we can go ahead and compile and see if this works.
Back.
Here at the end, and we can go ahead and compile and see if this works. Well, compile was successful. The other thing I said to do to make our debugging easier was to select the enemy, and we can go and change their speed by going down to their movement component and finding the walking and finding their speed. So max walk speed is 600 here. Let's set it down to, I don't know, 400. So we can
In a way, dude.
easily get away from them. They're going to walk a bit slow. And we go ahead and play. They're walking towards us slowly. We can run away. We hide behind a corner, and here they go, come looking for us each time. But hopefully, if we hide behind two corners, they won't be able to find us. So I hide there, hide here, and he's going to go and investigate at the last known location. You see, he's just poked his head around the corner, but then he's stuck there because he doesn't know what to do. And if we were to go and have a look at our behavior tree, and just put this over to one side and the game to the other, and give myself a little bit of room, then if we have a look at the behavior tree, we can see it's kind of jazzing around here because it can't do either of them. It's trying to move to the last known location, that's succeeding, so it's getting a bit stuck here. But if I come into view, you can see he's moving towards me. If he loses sight of me, then he goes over to the investigate condition. So loses sight, he's going to investigate, and then he comes and sees me, and then he goes back to chasing me. So this behavior is actually working now. We're able to do a choice between trying to chase and trying to investigate based on this blackboard behavior. Let's just change the name of this blackboard to behavior here to can see player question mark. So that's going to be much easier to read. Now we've got this selector, can see the player, then we should space. Otherwise, we should investigate, and we can delete this sequence over here because that is no longer in use. So hopefully now you've got a bit of a better understanding of how behavior trees can be linked together to create choice and sequence and put lots of tasks together to make more complex behaviors really easily. In the next lecture, we're going to be looking at how we can make our own custom tasks in C++ so that we can get some shooting action. I'll see you in the next video. Hello and welcome. In this lecture, we are going to be starting to add even more functionality into our behavior tree by adding a custom task, this clear blackboard value. We're going to make that entirely custom in C++. Let's dive in and see how to do it. Okay, so I'd like to expand out the behavior of this behavior tree so that we can get to investigate, and once we're done investigating, we move on to going back home. So I'm going to add a little move to task here afterwards, which just returns us to the start location. And what we need to do in order to get there is to have some notion of whether we've already visited the last known player location. And the way I'm going to do that is essentially by unsetting the last known player location once we have investigated it. However, we don't currently have a way of doing that. But first of all, let's create the decorator. So add a decorator to investigating blackboard that is going to be, I'm going to go and rename it to has investigated, like so. And this is going to check if the last known player location is set. And that means that we need to have some sort of node that allows us to unset a blackboard key. Now, that doesn't actually exist. You'd have thought it does, but it doesn't. So this is a great opportunity for me to show you how we can create a custom task. Now, you could do it very easily using Blueprint, or I'm going to show you the slightly harder way, but the one that gives you a lot of power, which is doing it through C++. So we're going to go over to our main content browser, go to Add New, and go to New C++ class, and we're going to want to Show All Classes checkbox. And then we're searching for BT task. And there's a ++. So we're going to go over to our main content browser, go to Add New, and go to New C++. Class, and we're going to want to Show All Classes checkbox. And then we're searching for BT task. And then there's lots of options here. You can see a lot of them are actually those built-in tasks, such as make noise, or there is a move to here, or wait. Now, you could go and have a look at the C++ to see how those are implemented. That's always useful. But what we're interested in is what should we inherit from? What should we use as the basis for our own node? Now, there's a couple of options here. You could choose to have a BT task node as your basis, or you could use the Blackboard base. Now, what's the difference between the two? Let's have a quick look. So Move2 actually uses the Blackboard base. And what that means is that it has this Blackboard key drop-down that allows us to choose a Blackboard key to work with. That means we don't have to hard code into our task the Blackboard keys that we're working with, which is great because it allows us to reuse those tasks in different situations. So if you need a Blackboard key, then the Blackboard base is a great one to go with. Otherwise, you use the other one. So let's go and add a new C++ class. Again, show all classes, and we're looking for the BT task again. And we're selecting the Blackboard base, hit next. Now I'm going to rename this to BT task underscore clear Blackboard value. And we're going to go ahead and create that class here. Now, initially this will fail, so let's click yes and see what the error message is here. It's saying something about LNK, which stands for link, unresolved external symbol, blah, blah, blah. Usually when you've got this kind of error from the linker, this is saying that you've got something in your header files that wasn't in your C++. Or, in this case, it means that there isn't a module included that we are relying upon. And based on the types of symbols that it's looking for, I can see here it's the iGameplay task owner interface, it seems to be looking for something to do with gameplay tasks. And that is a module in actual fact. So if we go over to Visual Studio Code and just open up the file browser, I'm just going to scroll up to my project, then under source, Simple Shooter, there should be a simpleshooter.build.cs or whatever your project name is, .build.cs. And in here, if I give us a little bit more space, you can see that we've got this public dependencies module names. And the module name here that we want to add to this list is going to be gameplay tasks with an S. And if we go ahead and add that and go back and compile, now hopefully everything should compile successfully. For whatever reason, this doesn't automatically get added when you override from BT task. Now, once that's done, let's go and have a look at what was created.
Okay.
Here, we should have a new class, which is our BT task underscore clear Blackboard value, and it's pretty empty at the moment. Now, what I want to do is if we were to add this into our behavior tree at the moment, it would have an ugly name. So we want a nice human readable name for this task. And the way we're going to do this is by adding in a constructor and setting a property. So let's create a public constructor here. The constructor always has the same name as the class, so we can copy that. Doesn't need to take any arguments, semicolon at the end, and then let's create the implementation over in the C++. And the implementation just copy that. Doesn't need to take any arguments, semicolon at the end, and then let's create the implementation over in the C++. And the implementation just needs to set a variable called node name. So if you set node name and then you use a string, then the string that we set is going to be the node name. So it's going to be clear Blackboard value, just with the spaces and the correct capitalization. Should be nice and easy. Now, one thing that I forgot to do at the time of recording is to surround this by the text macro. Now, you should go ahead and do that in your code, but you'll see that in my code it will persist in just being like this. And we should be able to go and compile that now. Awesome, that compiled. Go and compile that now. You should go ahead and do that in your code, but you'll see that in my code it will persist in just being like this. And we should be able to go and compile that now. Awesome, that compiled successfully. So I challenge you to add this new node. So add it to the end of the investigation behavior and just check that it completes. Basically, it should automatically complete without doing anything at all, but check that the name is correct, check that you're able to add it, and we'll look.
The node. Alright, there's an error on the screen. Oh, they're running. No.
And adding the behavior in the next lecture. So pause the video and have a go. Okay, welcome back. So let's go to our enemy AI and add in, at the end of the investigate behavior, we're going to add in our clear Blackboard value. You can see this.
Oh, whoops. Oh, nice.
Got the nice name there. And you can also see that if you go over to the details pane, you can select a Blackboard key. We're going to select the last known player location. Even though that doesn't do anything yet, you can see that we have that functionality because we inherited from Blackboard base.
No, we're gonna do that. Yeah, yeah.
And let's just check that it completes automatically. It should do. And then it should move on. Let's move it on to a wait task afterwards so that we can see that it just goes straight through or completes automatically. So I'm going to play. I am going to go and hide myself around a corner as much as I can. And then I'm going to go and have a look at the investigating. It went through and actually he's seen me. So let's go and hide again. Go and hide around the corner if I can. There we go. And then I'm going to go to the, there you go. It's gone right through the clear Blackboard value, which must mean that it succeeded, because we know that if it was a sequence and it failed, it will have stopped and not gone on to the wait. So that's working correctly. The clear Blackboard value is just returning success straight away and going on to waiting. The next lecture, we're going to look at how we can actually add in the functionality. I'll see you there. Hello and welcome. In this lecture, we've got our AI that is following us around the world. He'll go and investigate when he loses sight of me, so it's quite hard to lose. But if I go too many corners away, he's not going to be able to keep up. And eventually, he's going to lose interest and go back to his start location over there. That's what we're going to be implementing in this lecture by finishing off our behavior tree task. Let's dive in and see how it's done. So we want to get our task to execute, to actually do something, and particularly we want it to be able to clear that Blackboard value, do what it says on the tin. So how do we go about doing that? Well, for that we need to go up to our base class and have a look at what's implemented there. In fact, we need to go up one level higher, which as you can see from the inheritance of the UBT task Blackboard base, above that we have the UBT task node. So let's use F12 to navigate to the implementation there. And if you scroll up to the top of the base, above that we have the UBT task node. So let's use F12 to navigate to the implementation there. And if you scroll up to the top of the bttasknode.h header file, you can see there's the information about this class. And the most important thing is that these are the virtual functions that we're most likely to want to implement. So the first one is execute task. This is called when the task starts to execute. We then have abort task, which is when it's decided that we need to stop executing, for example, because a condition has become false and we've got that signaling set up, so it aborts this task. Tick task happens all the time that the task is executing, but not the first tick. So the first tick we'll call execute task. Thereafter, we'll keep calling tick task every time. And that's for behaviors that might run for longer than one tick, such as moving to an enemy might take multiple ticks. So tick task allows us to do something every tick. And on message is for other things other than aborting that might send a message to this task. We don't really have to worry about this particular function.
my laundry room almost sitting on the. I have a call right now. So I'm gonna go straight.
Yeah. I have the coffee made here too if you want. Love ya.
So the first three are really the ones we're more interested in. And seeing as our task is simply just going to clear the blackboard value as soon as it is executed, and then it's going to finish straight away, doesn't need to do things across multiple ticks, we're interested in the execute task. So if we search in this header file for execute task, you can see the full signature is here, and the return type here is this EBT node result. And it takes in two things, the owner component and the node memory. Now, the reason it takes in node memory is a little bit complicated, but the important thing to know here is that a task class, or a task class instance, there's only one of them per all of the blackboards, essentially. They get shared between everything, which is why if you want to save some information that's related to a node in one particular behavior tree, then what you need to do is store it in this memory pointer. But we're not going to be doing anything related to that. It's a little bit more advanced to need to do that. And there are other ways to get around this, such as allowing Unreal to create multiple instances for every behavior tree, which might be a little bit neater or not, but this is a slightly more efficient way, and we don't have to worry about it. Ultimately, what we're interested in is the fact that we can get to our owner component, the behavior tree component, and from there we can get to other things such as the pawn, etc. But that's also the subject of another lecture. So what's interesting and important now is just to implement our execute task. So we're going to copy the signature, go over to our clear blackboard value.h, and let's just see, is this public? No, I think this is going to be protected because it's in the default section. So we're going to create ourselves a protected section. And paste it in there. And then we're going to go ahead and create the, or put an override just to make sure, be safe. And then we're going to create an implementation over in the C++, remembering that we always want to be calling to super when we're overriding. So super execute task with the owner component and the node memory being called up to our parent here. And then what we want to do is get hold of our blackboard so that we can clear the key. And there's two things that are important here. First of all, how do we know what key was selected? Well, if we go to our blackboard base.h, you can see that one of the methods there is get selected blackboard key. So you can easily just call this in your C++, get selected blackboard key, and that's going to return, if we hover over it, it returns an fname, the fname of the blackboard key that was selected in the behavior tree. Now, the other thing we need to do is to be actually able to get hold of the blackboard related to this behavior tree. So for that, we've got our owner comp. Now, notice here that the type of owner comp being passed in here is actually a reference, not a pointer. So it can't be null for a start, that's great, but it also means that we need to use the dot operator rather than the arrow operator because we're not using a pointer. And from here, we can simply get blackboard component. So that just gets the blackboard component. If you hover over it, this one is a pointer to a blackboard component, so you will need to use arrow operators. So we already know how to clear keys on blackboard components. That's going to be your challenge. So hopefully the challenge is not too complicated. You want to clear the selected key. You can check where we've done this before. Do you need any includes in order to do this? Maybe the blackboard needs an include. Use the key selected in your behavior tree as the key that we want to clear. So pause the video and have a go. Okay, welcome back. So let's give this a shot. So the first thing is we've got our blackboard component. Let's use the arrow operator here. Nothing is coming up, so I'm assuming that I need, and indeed there's some red squigglies, I need a hash include here to do the behavior tree and then the blackboard component here. And now hopefully my autocomplete should be working, which will allow me to have the clear. Let's just try and refresh our memories. Where have we done this before? If we go over to Shooter AI Controller CPP and have a look at what we've got here, we've got clear value. That's the one we're looking for. So let's try that, clear value. And what's it take in? It takes in either an F key or an F name. Great, F name we can get. And where did we say we could get that? With the get selected blackboard key that is on this class because it's in the parent class. So get selected blackboard key, and it's as simple as that. We're clearing the value of the selected blackboard key. Now, one final thing we need to do, this wasn't part of your challenge, so don't worry if you didn't know this, is that we need to return, because there is a return value for our clear blackboard value execute task. And the return value is quite interesting. Let's have a look. Let's follow it with an F12 and see what different statuses we can return from our execute task. Now, the first one is succeeded. Great. That basically signals to the behavior tree that this node is finished executing and we can move on to the next one. Failed. Again, this is a finished, so we can move on to the next one, but this time it's saying that it failed. So that gives the different indications to, for example, our sequence nodes or our selector nodes as to what those nodes should actually be doing. Then we have got aborted, which is basically the same as failure, and we have in progress. If you return in progress from our execute task, it's basically going to say you've got to keep calling tick until I tell you otherwise, until I say that I have finished. Now, we're not going to be using this, but it's good to keep in mind that if you need to create a task that is long running, will run across multiple ticks, then we're going to have to return in progress. But as I said, we want succeeded. So let's go in and do that return, EBT node result, colon, and it is going to be succeeded because we succeeded to clear that value, basically no matter what. So we can go ahead and save all of this, go over into the editor and hit compile. And when that's complete, let's go ahead and open up our AI and the behavior tree. So where's that one? BT enemy AI, dock it to the main window. And let's have a look. We've got our clear blackboard value, which should now be able to allow us to move to the last known location, clear the blackboard value, wait for 5, and then we should see that investigating this last known player location should be unset, so we should move back to our start location. So let's see if this behavior is now working now that the task is fully implemented. So he's coming over to me, he's investigating me. I'm going to go and hide. So let's go and hide. Oh, he's coming to investigate. Let's go and hide again. So we'll go and hide. Let's see if we can spot him over there. He should be waiting at the moment, and then he's going back to his start location, which unfortunately makes him intersect with me. So let's see if this is actually working as we expect by bringing out our enemy AI window and docking over to the right and putting our main window over on the left. It's a little bit cramped, but we can make do. And then we're going to try and escape this guy one more time and see what happens with his behavior. You can see he's moving to the last known player location. And now he is waiting, having cleared the value, and then you can see he's going to move 2, and you can see these red bars on the decorators are telling us that neither of these two conditions are true, so we can't do either of those. Finally, he's moved to the start location, so now it's flickering because basically it can't do anything. So that basically is that. In this lecture, we've seen how we can get the BT tasks to execute code, understood the different statuses that you can return from execute task, how to get the blackboard from the task, and also how to get the currently selected key on a blackboard task. In the next lecture, we're going to see how we can get hold of the world outside of the blackboard behavior tree, how we can get hold of the pawn from within a behavior tree task. I'll see you there.
Okay. Sounds good. See you there. Need to hit play, obviously. Obviously. Funny that Kick has an Overwatch 2 option, but Twitch doesn't. Like, who's playing Overwatch? I mean, Kick has an Overwatch 1 option.
I will not leave a broken world behind. Double kill confirmed. Sweet dreams. I am unbreakable. I won't let you fall. What the gnome? أنا ما حدش يقدر علي.
You had wait.
Taking damage.
No, it's can't have top teammates. Interesting. Feel like you should.
Choose your map.
No brainer, right? No brainer. What? Push? Damn, boo! Boo! Gotta let them know we're not happy.
Select your hero. Choose heroes to ban. Arrival at consider.
All right, team. Calm early, calm often. Said it once, I'll say it again. I always calm early. Never not calmed early. There it is.
I will not leave a broken world behind. Just one more mission. Peace.
5, 4, 3, 2, 1. Objective unlocks in 30 seconds.
If I'm getting dough, I'm gonna switch to Brig, but you know. Oh, but probably definitely gonna switch to Brig since we got a Zen boy. Alright, that's died. Let's see. That's not enough for me to swap.
I still have some fight in me.
We don't really. Ana would be best for Echo. Currently.
I see. Enemy in sight. For your wounds.
Reloading.
You're powered up. Get in there. With me, with the
I'm behind her. No, she's better than me.
This is not the end.
Your team is close to taking the lead.
Where we at? Okay.
My ultimate ready to activate. My ultimate is ready. I'm ready. Stop them from pushing the barricade.
We got barricade. What are we doing here?
EMP
Bro! I suck.
I'm not finished.
Feel like we're forgetting something pretty important here, people.
They've taken possession of the robot.
Activating Tiger Strike sequence.
Dear. Don't fret. I see you.
I'm coming in hot.
Nanotooth almost ready. Reloading. Heal me. My ultimate is fully charged. Get in there.
Ready to activate the
Targeting
My
hostile.
ultimate is ready.
Warihum with it. You're powered up. Get in there. Eyes on target. We're catching up. Targeting hostile. Rake.
Activating Tiger Strike sequence.
I'm reloading.
Start pushing the barricade.
Don't fret. I see you.
What are we doing?
Enemy in sight. No recovery. Targeting hostile.
Bruh.
I won't give in. Stand up straight.
Coming in hot.
You're powered up. Get in there. You're fine.
Let's get this to the new spawn. Please, all the way, go. Bruh, fine, I'll do it. Hey, for real? Yeah, I mean, like, I shouldn't be doing that.
You'll have to try harder than that.
My ultimate charges. My ultimate is good to go. EMP ready to activate the EMP activated. Blocking satellite vector. Activating Tiger Strike sequence.
He's here. He's close. Oh, he's under, I think.
Stop them or we lose the lead.
Nanook, we need to put a stop to their push.
30 seconds.
You're powered up. Get in there.
Experience tranquility.
Overtime.
No way! Are you serious? Oh, hell yeah.
Someone needs to fill this saddle. You tangled with the wrong man. I'm really feeling the heat. Pardon me. Someone needs to fill this saddle.
I always give up. One less to worry about. I always get my mark.
Select a map.
No wrong answers here. No wrong answers. No. No.
Select your hero.
Roberto.
Choose hero bands.
Oh boy. Oh boy. Roberto.
Welcome to Jungle. Prepare your defenses. Select your
Defense. 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 Defense.
I will not leave a broken world behind. Isaiah.
I'll be watching your back out there, Lieutenant.
You have nothing to worry about, Captain.
Midday? Midnight?
You answered Winston's recall. Even after all you went through.
If I'm called, then I do not answer. What is left, Anna?
You are.
You are left, Reinhardt. And that is nothing to scoff at.
1. Attackers incoming. Stop
Make to the face. Take some damage, Ryan. Let me get my target. I'm reloading.
Cover each other. We need to slow that payload.
We're outnumbered. Be careful.
Run away! Don't do it, Junk.
The payload has reached
Enemy in sight.
Don't do it, Junk. You're by yourself.
Everyone push that payload back.
Eyes on the target. Wait for me to reload. Enemy in sight. Enemy here. Keep fighting.
Ryan needs help. Ryan needs help.
Fortified. Covering you.
minor perk unlocked.
Where's an Ash? Where's the Ash? Where's the Ash? Huge.
Healing you.
For the Crusaders!
Time for the reckoning.
Not ideal.
The Iron Forest watches over you. Eyes on a target.
Fucking enemy Sojourn. Sojourn, I'm ready to nano.
You're powered up. Get in there.
Mecha's higher.
Coming through.
Ahlan. Take this.
Ryan, can't see you. You're completely by yourself. Buddy.
Covering.
Sorry, I had to kill that dude. He was trapped, I think. I know it came at the cost of my own life, but you know what? I don't
Okay. Okay. We're stabilizing here.
Enemy in sight. I appreciate it.
Ooh. We're here now, Ryan. We're here now. Point. Let's go. Point. Let's go. Point. Can't see you there, Ryan. I'm getting out.
Keep your eyes peeled!
Keep an eye out. Eyes on a target.
On as well. Oh, who hooped him? Yeah, we're kind of getting pinned in here.
This is not yet.
its destination.
Uh.
I will not leave a broken world behind.
I prefer to walk alone, but I suppose you will.
I heard town failed another mission. Going soft.
Do not speak to me unless you wish to lose your other eye.
I'd still be the better shot.
Work together and we'll make it through. Over here.
Five,
Over here.
4, 3, 2, 1. Attack commencing. Escort the payload.
We're moving out. Expect resistance.
Suspicious.
Over there.
Enemies there. Let's kill them out.
Over there. Hold on. Suppress this target. I have you. Keep fighting.
Left guys are behind.
You're welcome.
Hostile here.
Covering you.
Trish is back.
I see you. Need to reload. I've got you. Enemy in sight.
No one can hide from my sight.
Eyes on a target. You're powered up. Get in there. Targeting hostile.
What? How is that? Bro, terrible ults.
Humanity is shattered.
Brother, I stink. I stink, brother. What about though?
Dodge this. Next time, think twice.
Time again to try again. So sick with a punch. You will be renewed.
This ends now.
Receive my aid. Need a minute to recharge.
Bruh!
60 seconds.
Let's get back to basics.
Not great.
You'll learn pain only glimpsed in death.
I'm taking damage.
Let's get the payload.
Oh, we're still here. We're still here. That's huge. still here, we're still here.
Don't engage, don't engage, don't engage.
There's a point, lock a point, lock a point.
Sick beat.
Dive life weaver, dive life weaver, dive life weaver. Oh, it's so low. Bruh.
My essence has reformed.
Oh, what are we doing? Healers first if we can. Tracer on point, both of us on point.
Time again to try again.
The payload is moving. Enemy here. Over here. March affirmative.
Well done. Plenty of time, plenty of time.
Big stanger lap.
That was awesome. That was awesome.
Over here.
Almost ready.
Leave this place to me.
Appreciate it. Surrender to your mother.
That's pretty easy enough for us to get out. Lucio, yeah. Treasure. Treasure solo. Queen. Weaver. Treasure red low.
Time for the reckoning.
Healers first if we can. Call something. Sojourn left. Healers. Lucio.
Surrender to your mother. Receive my aid.
You should come home, Genji. We need your help.
There are others in the world who need saving.
When I was a kid, you said you'd always be there for me.
You are old enough to know it's not that simple.
Let's get this mission started.
We will be the lightning that rides the storm.
5, 4, 3, 2, 1. Attack commencing. Escort the payload.
Do this.
I gotta bash him.
I have to swap.
The breeze brings relief. Enemy here. Purify. Hey.
See if I can get out.
I licked my wounds. Let's go.
Take point, take point, take point. Take point, take point, take point.
Hey. Time for the reckoning. Time for the reckoning.
Queen's good, dude.
Round 3. Complete. Score 3-3. Switching sides. Major pack unlocked.
Another battlefield.
Stay close to me and I'll keep you safe.
Got dust stuck in my teeth.
Not all of us are scientists, but that's no reason to be careless.
Whoa, you can fly.
Five, 4, 3, 2, 1. Attackers incoming.
You're not?
Stop the payload.
Never happened.
Fuck you! I suck! I suck ass! Yeah, my bad, I just threw.
Receive my aid. Major pack unshackled. I hold the key.
The payload is moving. Has the experiment been compromised?
A sip for the parched.
frustrating. Incredibly frustrating. Incredibly not fun.
Vote for your map.
You're under arrest.
King Drone!
Huh?
King's Row! No. Who's the doof?
Oh!
Wow.
Holy shit.
Select
This tank is not great.
Good thing is on your webcam mic, by the way.
Ah.
You want on like a webcam mic, I think.
Is this microphone not? Hello? Is this microphone? Is this any better?
Hi.
Hi. Oh, I forgot to ban yours.
Silly.
Oops.
now entering King's Row.
Bottom 500. That's great. Defense. 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 Looks like somebody's getting nanoed.
Maybe.
I will not leave a broken world behind.
Only one invoice means you're getting every single nano.
Excuse me, what about me?
Okay, we got two contestants.
Nano Juno?
Yeah, June. Nano.
Yeah, I think
Don't do that.
I'm just gonna stop playing, I think.
Don't do that, I'm bad. Don't do that, I'm bad.
Chop them into currywurst.
Scary ass Ryan skin, what the fuck? Oh. Scary ass fucking Ryan skin.
Isaiah.
Ugh, get the fuck away from him.
I'm kind of back in this corner here, by the way.
Defend objective A.
What was one?
Keep you up. Take this.
I don't know what today.
Let me regen my shield. I'm gonna wait here for like 10 seconds. Don't let this water image out.
On behalf.
I won't let you fall. I needed that.
Can't see that part, Ryan? Can't see Ryan? Can't see Ryan?
I need to reload.
Widow still up top?
Oh no, not the Widow mine. Not the Widow mine.
You're going to live.
She's kind of bad.
She ain't good.
Don't fret. I see you.
They don't see you, Tracer.
Back up a little bit, Ryan.
I won't let you fall.
Why am I the one she hits a shot on?
You know, support is gonna happen.
I'm backing up.
Be careful.
No, that's embarrassing. I died to her. She kind of bad.
Another one.
Yeah, I'm about to get a 9-man shatter.
Hold on. Reloading.
Ooh,
I was touching.
not worth. Hold,
That's a
hold,
load
hold,
of crap.
hold. Ryan, I can handle you. Ryan, come back, come back, come back.
No one can hide from my shadow.
Hell no.
Can you sneak out, Ryan?
Sorry, half.
Get in there.
Wow, I shouldn't have crouched. That was totally a fucking body shot.
Next time, say please. Targeting hot side.
It's actually so sad for her.
I am unbreakable. I'm reloading.
I can keep him on Widow. I just need to play Widow.
Beep, 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 beep.
The enemy team is pushing the payload.
Yo, I'm about to kill everybody. They just gotta scoot up. And they don't gotta.
Far left, far left, far left. Nano, or anti. They're off a Widow.
Keep fighting.
Far left, far left.
Taking care of you.
To establish orbital reconnection.
Genji is gone.
Oh, that was solid. Little 1-2 punch.
I won't give in.
Gonna regen my shield and push in about 8 seconds. No, hell no.
Wait,
Actually,
this out,
I'm
wait,
about to
this
kill
out,
everyone.
wait,
Get in there. Targeting hot spine.
behind, behind, behind.
Stand up straight. That one thing. The Eye of Horus watches over you.
Yeah.
60 seconds.
Ryan, too far, too far. I'm gonna reposition real quickly. On LOS for like 5 more seconds.
Standing the payload's way.
Well done. Canazzi, you out there?
Seconds remaining.
Hold on! We have only seconds left!
Gino is low.
You're fine.
10 seconds.
Time is short. Hold strong. أنا محدش يقدر علي.
Just clear point, just clear point. On a dip.
You're powered up. Get in there.
And don't you know?
Now it's my turn.
Score 0-1. Switching sides.
Hey, you open that door?
Prepare to attack.
Okay.
Select your hero.
No, I didn't open it after. There's a pillow on the ground? That's what you say? Nah, wow, thanks for putting the carpet down alone. Are you leaving right now?
Hi.
Sounds good. I mean, I'll be home at like 5:30ish. Why? Oh, okay, sounds good. That's it.
You're hard to keep a scope. I will not leave a broken world behind.
Oh, I'm sorry.
Don't be. It keeps me sharp.
5, 4, 3,
Yo.
1. Attack commences. Capture objective A.
Enough whining. Goodbye.
Rhinoff, Rhinoff. Oh, almost left him.
Keep fighting.
Yeah, can't see you, Ryan, can't see you, Ryan.
I'm just baiting him to move. No sleep dart on Ana.
Oops.
Oh, damn. That's my fault. I was line of sighting y'all. Alright, I'm gonna do the same thing. I'm gonna go front and then back out and pretend like I'm going to the little room on the left and then go back to front. Just so they all group up in one little pretty little line.
Can you hold shield for a second so we can transition to back right?
Yeah, I got you. There's a trap around here somewhere.
Already got it.
Broke.
The shield's up. Alright, I'm
That's
gonna
huge, that's huge.
God damn it.
Anti, swing that hammer, swing that hammer.
Good anti-nade, you mother. That's it, just mother.
No, grandmother.
Grammy.
Granny, baby.
This guy's here meeting 60-year-old woman.
Widow. Did we just win? I think we did. Oh, that's huge. So large.
Huge.
Hi. Go take some space, Ryan. Get out there. Go do your job. Oh,
Yo,
I
I'm
hear
about
Junk.
to
I
headshot
hear
somebody
Junk.
with this nectar shatter.
Junk's flanking. Oh, so huge. He's trying.
About to block his assist.
Just walk past
Watch
him
that
and,
flank.
walk past him and get their back line. Oh, huge block. Huge block. It's too large. It's too large.
That's mine too. Don't
I'm
walk
running
in a
away.
straight line.
I'm running away.
Stupid. Alright, we see where it's my bad.
That got real smooth. Yummy. GG's.
GG's, yo.
Cha-cha real smooth. There's water in me. Did you have your post-workout drink?
Oh no. I have it. Oh.
Okay, it's out. Yeah. Yeah. Go to work. Little left. Take it back now, y'all. Won't hop this time. Bam. PUBG is one of the top watched on Kick. PUBG Mobile? That doesn't seem right. Cha-cha again. Open. Go to work. This is probably the one that I have.
Find your part, get set, go. ShopGranger.com for the product you need delivered.
Hello everyone, this is me Arijit with a new video, and in this video we will talk about how you can use a Raspberry Pi Zero W with a Raspberry Pi camera, because as you know that this camera doesn't fits into it. And also, so we are going to see how to use this camera with this module. Also we'll see how to write a code in Python to take images, and also we'll see manually how to take images using Raspberry Pi. So let's get started. Okay guys, so if you see here, this is the W, and if you just look closely here, this is the camera port in W. So if we just try to put this camera inside, it's not going to, because the port, so this
Okay, let's just see what happens when I plug this in, because technically, I don't know what is going to happen since the Pi string. Oh wait, I think it's set to the other one, actually. Should be good. No, we want... Yeah, PowerShell, right? Bird. This is something we can very quickly print. Down, 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 down. Catnip bubbles. This is actually kind of sick. Don't allow my location, please. Thank you. New. What am I doing? Uh, why isn't this working? Delete. 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 Very good. Dum 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 dum. This should actually be. Let's make it 37. Bro, what? And then I want to extrude the sides, is that right? Well, actually, no. We'll make the outside 40. Maybe do like 5mm screws, 36, let's say 37. 43. Why is this happening? And then we want another square. This will be 37, 37. And then this distance should be 6. This distance, oh wait, no, this distance should be 3. And that distance is 3 as well. Fuck it. And then we can extrude. Two millimeters. A circle. Oh wait, no, we want to create a sketch. Jeez. What? Did I not save that extrude? Two. All right. I want this to be Struct? No. Go back to here. I don't know what I did. Oh, here we go. How much does the upgrade cost? What? No shot.
Imagine being able to build anything, for any reason, in any style.
Alright, welcome back friends. In this video today, I'm going to be giving you a step-by-step guide for getting you up and running with Fusion 360. If you're new to the channel, my name is Ty Writings. I've been 3D printing as a hobbyist all the way around. So there we go. We made a part. The last thing you're going to want to do is make sure you save it. Save, version description. So what does this mean? If you look at our test design name that we gave it when we saved the file, it had V1 next to it. So what that means is every time you save your part, it's going to uprev the version of it. That way you can kind of version control the part that you make, meaning you can go backwards on your versions and see where you left off at different stages of the design with every save that you have. And what's cool about that is you can give it a little description. So for this one, I'm going to say initial part definition, and I'm going to hit OK. You don't have to do this. You can just hit OK. It doesn't really matter if you don't care about tracking this right now, but it's just something nice. You know, if you come back to your part in a couple days and there's a piece that wasn't working and you tweak one of the holes on here, for example, you can save it and say, made the holes bigger or something like that, or made the holes to 12 millimeter or something, just to give yourself little notes in your version history to see how you were changing it over time. I hit OK, and our part is good to go. So the last little bonus tip I'm going to give here is if you are into 3D printing, which I'm hoping some people that find my channel are, say you want to 3D print this part. We have saved the part, everything is good to go. But what's cool about Fusion 360 is it has this little utilities feature. If you click over on utilities, it's got this little box with a little point inside of it and it says make. Hit the make button and you can hit 3D print. It's going to give you this little menu in this latest update of Fusion way, which is by using the whole tool under the solids tab up here. So we'll click on that. I'm going to click on this surface. As you can see, it says face.
I don't know. I need. Yeah, I don't know what that is. Oh shit, what am I doing? Delete the whole, baby. That's oh, there we go. You know what? We're literally just gonna print this.
Sketch.
Utilities, make 3D print.
Points, and it's highlighted saying select. It's telling us to pick a place we want to be, how you were.
When I see other underdogs hurt by a rigged system, I fight back.
Congressman Raja Krishnamurthy speaking out against terrorists
and putting an end to bullying.
And as your senator, I'll take on the biggest bully of them all. I'm Raja Krishnamurthy, but you can just call me Raja.
Like a good neighbor.
Okay, Raja.
There. I was gonna say that.
Jake.
We're changing it over time. I hit OK, and our part is good to go. So the last little bonus tip I'm going to give here is if you are into 3D printing, which I'm hoping some people that find my channel are, say you want to 3D print this part. We have saved the part, everything is good to go. But what's cool about Fusion 360 is it has this little utilities feature. If you click over on utilities, it's got this little box with a little point inside of it and it says make. Hit the make button and you can hit 3D print. It's going to give you this little menu in this latest update of Fusion 360, and it says preparation type. It has manufacturing selected right now, but we want to do export. You can now, it says object and it says select. That's telling you to pick what thing you want to actually 3D print, which for us, we can just click on this whole body. We will save it as STL. This has always worked perfectly fine for me with the binary format.
Wait, do I need to join these? Okay. Utilities. Make. 3D print. Export. Come on, brother. Let's modify. I'm going back to the tutorial I was watching yesterday. Here's my history. Lilyboo. Sorry, I missed this a while ago.
Unit type is millimeters.
No.
When it came time to take things to the next level,
Shut
I knew that I had to make a website, and Wix.
Welcome to this big plane to draw. You want to put the line in millimeters. All we want is obviously this one here, so we'll select that. Everything else we'll leave as default. So I'm down it from view as well. Design, ready to be like on the solid. Press enter. Okay, so the base plate is looking good. Now let's go ahead and model the bracket. So to do this, let's come up to the top. Let's come under File, and we'll click New Design. And then we're going to go straight away and save that. I want to call that bracket. We want to make sure that its location is under our project. So Fusion Tutorial, that's good. Let's click Save. Now let's start to model this part. So we're going to do this in stages, and first of all, we're going to start with the footprint. So again, let's go ahead up to Solid. Let's create a 2D sketch. And let's select the XY plane. And then we're going to start with the rectangle tool. So 2-point rectangle. Again, we'll start at
what are you two doing? Delete the base plate. Delete. Okay. Delete. 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 Bruh. We're going to new design.
Solid. Let's click Save. Our project, all that. So to do this, let's come up to the top. Let's come under File, and we'll click New Design. And then we're going to go straight away and save that. To call that bracket, we want to make sure that its location is under our project. So Fusion Tutorial, that's good. Let's click Save. Now let's start to model this part. So we're going to do this in stages, and first of all, we're going to start with the footprint. So again, let's go ahead up to Solid. Let's create a 2D sketch. And let's select the XY plane. And then we're going to start with the rectangle tool. So 2-point rectangle. Again, we'll start at the origin. We'll bring that out. And the horizontal dimension, we'll add in 80. We're going to hit Tab on the keyboard, add in 80 on the vertical. Press Enter. That's looking good. Let's get that chamfer in. So let's go to the line tool, roughly position that in. Now I'm going to select the dimension tool. Endpoint of the line to the origin, 20, yes. Other endpoint of the line to origin, then 20, press enter, that's good. Let's go ahead and add this hole, so the center point circle, put that anywhere for the time being, and that has a diameter of 30 millimeters. and we'll sketch dimension that. So circle to vertical, going to be 40, then circle to the lower horizontal, it's going to be 40 as well. And then from here we can finish the sketch and we're ready to extrude this. So again, we'll come up to solid, select extrude, make sure that we select this profile here, not this one or this one. So left click once. Then for the distance here, we've got a distance of 10 millimeters. Leave everything else as the default. Yeah, new body is correct. Press OK. Take a look at that, looking nice. Now the next feature.
New body, what?
Or this one. So left click once. Then for the distance here, we've got a distance of 10 millimeters. Leave everything else as the default. Yeah, new body is correct. Press OK. Take a look at that, looking nice. Now the next feature we'll add is the sidewalls. So that's the wall going along here and then down here. So to do this, we want to sketch on this face here. So we'll create a sketch, and then we've got the 3 default planes there, which we don't want to select. We can select faces of our 3D body. So let's go ahead and select this face here. We'll look perpendicular at that. Then let's go ahead and use the 2-point rectangle tool. We'll draw in the wall at the back here. So start in the corner. I'm just going to snap anywhere onto the vertical line there. Then we can go ahead and dimension that. So our dimension between this line here and this one, and it's got a wall thickness of 10 millimeters. It's 10.
And then you hit OK. And up here you can make it, test, block, 3D print. And down here where it says save to my computer, you can click on these little 3 dots, choose your file path for where you want to save this at. I always tend to put it in my 3D printing modeling folder, and then you'll.
I use Bamboo Studio too. Name would be camera base 0. All right, well, let's try it. I don't know where this is saved now. Print, here it is, test. Camera base 0. Huge. Bamboo. 15 minutes. Meantime. Oh, you know what? Shit. What is it doing? Oh, heat bed preheating. Duh. 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 What are you doing, Momo? Yeah, yeah. Oh, that's a little bit bigger than I thought it would be. This is uh 3D picture. Okay, I'm about to buy some calipers. I can already see this 3D print is too large. I did about 2 seconds of looking for a ruler. Calling it. I'm just gonna buy the calipers. Do have a measure kit. Oh shit. I'm running this, aren't I? Oh, it's like a frickin' oh, definitely need to measure those too. Interesting. But I forgot about that. There's already got ten, 20, 1, 2, 3, 4. It should be 25, maybe. Actually, let's do 24 on the nose. And all right, so this was, I successfully made it. It's done. Let's take this off, please. All right. This was 35, I believe. Let's measure. Just for Sandy's sake. 2. Oh, wait, I'm measuring the wrong one. Inches. 1, 2, 35. Yep, pretty on the nose. Okay, so this is 10 millimeters too big. Okay, so I'm pretty sure if I do this, we can edit sketch. Extruded the base 5. Take the snout. Five is actually pretty much on the nose. Okay. Okie dokie. There we go. Needs to be 17. What's the width here? 17 by 2. Okay. $17 minus 30. What was it? 30 minus 17. 13 divided by 2, 6.5. How far from the top is the question. I think 2 is pretty safe. Okay, now we want to extrude this guy. And we have 4 holes that are pretty hard to measure. Just under 2 millimeters. Oh, fuck. Those are in the thing, though. I mean, that's going to be like half. Oh, it goes to the center. Probably 1.25. I mean, I'll leave it there for now. Can I copy this? Don't know why that's happening, but we'll just say it's 1.5 on that side too. Okay, so nope, we want this, we want this. Okay, and then try to measure this. We'll call it 10. Oh, okay. Gotcha. All right. I think you mother. Um. All right. Let's try it. Dum, 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 dum. What was I doing? I think I just died or something. It's not what I want. Oh, we got some goop hanging here. Oh, break the goop. No. Well, I guess that's fine. This looks like it's gonna work. Got a good feeling about this. Okay. I would like these. Do that. We'll do that. Put one here. Sword in there too. Okay. And we'll put 64 cob. Kublai Khan. Dum 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 dum. Oh, hell yeah. There we go. Perfect. This is hot. Oh, this is hot. Damn near perfect. It's ever so slightly too big. Or too small, I should say. Oh, I definitely don't want to do this too. So this was 2 millimeters. Sugar. Well, it's pretty much, it's like right, it's there. Now it's stuck in here though. Don't. Oh, maybe I can use this. It's not strong enough, is it? Pop that out. Can I put options, music and sound? Dum 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 dum. What is this? Kind of aggressive. Pop this in. Come on, baby. There we go. Alright, I can either fan some of this PC board off. Sounds like a terrible idea. Bum 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 bum. You bitch. Oh, you fucking bitch. Get off the edge, you hoe. Just be at the ready to freaking hit me. Or space here, please. Scary. Zombie villager! Zombie villager! Out of drill. Did I kill my fucking zombie villager? Got no wood? would be pretty much game over if I. You know this happened? You joshing me? Okay, well, look here. My boy's still alive. This boat, please. This can be. Alright, I'm gonna let you out here, son. Owie, owie. Yes! Oh. There's another zombie villager in there. I can barely see this. Oh, good. Fuck you. So dark. Let me turn the lights up a little bit, please, huh? What's a dude got to do to get some lights on in this place? Download some mods. Some packages. Dun, dun, dun. F that mycelium. We don't give up. F about mycelium. Alright, F3. We're in a dark forest? All my homies hate mycelium. Here's my water. No reason to have these split. Visually sure. It's gonna be kind of tough. That was a villager, that was a villager. Alert, 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 alert. F you, dog. Okay, now I need to get into the Nether. Which I can do pretty much. Oh, I don't have gravel. What the fuck? How do I? We need a flint. I didn't lose my bucket, did I? Holy shit, I lost my fucking bucket. Carrot. That's absolutely massive. That's so big. Okay. I lost my bucket. Which is not ideal. Like that.
Alright, well, I guess I'm using my fucking iron to make another bucket. Which is ass. Oh, with the freaking bucket too. Is there more lava at the other spot, or is that... Lights! Come on! Come on! String. Yes, yes, yes. Bows. Solo pizza. Are there other ways to make gravel? Oh, I almost fucking very cool. Oh, fuck.
Very careful. If you're playing the same game, you get lava or buckets and very simple. Now, place the top of the rock and place it there. And then place it in 2 planks, like so. Here it's
Is that a full health bar? Was not. Was not. Pick up. There we go. Catch that shit on fire. Well, it's raining actually. Oh, come on. I'm gonna go sleep. But I actually need to skedaddle here too, 1208. That's a potato! It's pretty large. Pretty large. Do do do. Do 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 do. Jeez, there's a lot of freaking wood in this. This guy just sprouted. Did I lose my mycelium? No, did not. Would be pretty devastating to fall off. I ain't gonna lie. Bows work. Bows work. Yeah, I really gotta go. We're up to 2. Okay, I'm out of here. Peace out, y'all.